Today's video is the Midland 98 Plus, and these came from around 2001. Now, we don't normally do end user repairs, but this is an end user, and because of the serious situation we're in with the coronavirus, I have decided to do this for him. Comes with the factory original mic, which is an up, down, and an EU/UK button on there, because it's an 80 channel set under the PR27 licensing. Now, there was a time when we had these in all our vehicles, and we had 3 vehicles at the time, and when I bought these from the wholesalers, I didn't realise that the scan button, all it does is scan the 40 channels and stop. So if you're on channel 31, which you tend to use, you press scan, it goes through those channels and goes back to 31. I thought it would work in a normal way, that it scans indefinitely. Anyway, it doesn't. So that was a disappointment. And then we've got this ESP thing, which is some kind of signal processing. Never worked for me, but there you go. So apart from that, I mean, they worked as you expected them to work. They worked quite well. And I think the customer says this one is intermittent on transmit. Now, these can have dry joints. So now it's come with one side screw, so I must remember to put that back on, because I've got a memory like a sieve. So I'll open this up, and then we'll... Oh, well, before I do that, because we bought 3 of these at the time, the instruction book came with the circuit diagram and the layout. And so there's a scan from the instruction book of the circuit diagram. There's the scan there of the layout, which I've blown up, and hopefully we've got the alignment details there, because all I ever did to ours was adjust the deviation. These also support an external S meter through a 2.5mm jack, and I will demonstrate that because we do have one. So we'll open it up. So with it connected up, it's booted up on channel 9. Now, this being a customer's and him being an end user, I'm going to do all the service work on channel 1, so it's in the centre of the band. So I'll just make sure it's on UK. UK, EU, UK. So channel 1 puts it in the centre of the band, as it would channel 40 on EU. So we don't normally do them like this because our trade customers want them to work on 2781 format best when they're an 80 channel set. All I've got to do now is find the trimming tool. Okay, so going into transmit, and we ain't going to do that, is it? Unplug the extension speaker. So going into transmit, and we have absolutely nothing happening. The radio is going into transmit, but there's nothing being generated. Now the VCO is locked on transmit. I noticed there's some microphony on receive, which we'll come to. So that does sound like a dry joint, or even a Duff ceramic filter there. So we're going to do some fault finding to see why there is no transmit. So we've got transmit now. I've been over this for some dry joints, but it's still not right. So if I press transmit, it swung straight across. If I bang about with the screwdriver, you can see there's something amiss there. So we'll have to go... before you think they don't solder these properly at the factory, it's not the case at all. What happens is that when these are assembled, when you get an electronic component, for example this resistor, if these leads haven't been cleaned properly, then the product will, when it gets put together, and it works great for, you know, the year of the warranty, and then the leads are tarnishing inside the product and they cause the dry joint. So it's usually because the components have been in stock, perhaps in a high humidity environment, and they just get tarnished. So they all need to be cleaned. I don't know what the process is in manufacture, but this is what happens to these. So it's lack of cleaned leads rather than lack of being soldered properly. So I'll just carry on finding those dry joints. Okay, so we've gone over for a few more, and we seem to have a stable transmit. That's on the 3-watt scale. Let's see what it's doing. So there's 5 watts, so 4 watts should be just there. It's just doing 4 watts. It's what you want, isn't it? Radio that does what it says on the tin. I will have to put an inline fuse holder in this. It's come with it chopped out, and I don't like that. Okay, so we'll just go through the alignment. So transformer 8, just making sure again we're on channel 1, having turned the radio on and off a few times in that dry joint procedure. There we go, that's peak. That's peak. So what's next? Transformer. So it's transformer 8, 9, 10, 11. And transformer what? Oh, it's L3. And there we have it. It's still 4 watts, but it's now optimized. So I need to find out which the meter preset is. I might be wrong. It could be that one at the back, but that could be for the external meter. So we'll just see, because it doesn't matter what I upset, I can get it back right with the test instruments here. Yes, it is. That is the S meter. Sorry, the transmit power meter. So that's now set to the same 4 that the radio is actually doing. So make a note there. TX power meter. Okay, that brings us to deviation. Put the oscillator on. I'll have to retune the signal, the test instrument, because we're on a slightly different frequency with it being channel 1. Well, if that's true, that's very, very low. Wallow. Wallow. Good grief. It's 0.9. So the preset just here, I can't read the thing well enough to tell you its number, but the one near where the power lead goes in is in fact deviation. Can you see that's dropped down? And that's on maximum. So that's 1.9 with the instrument on, so just do a quick whistle test. Wallow, that's actually spot on, but it needs to be on full, which isn't nice. You'd prefer a bit of leeway there. What I failed to mention before tuning up the transmitter is that the preset potentiometer here is the TX power, and I will just demonstrate that for you. So we'll just go backwards a step. So we're on 4 watts, and we can turn that down, we can turn it up, and we turn it up to the maximum it does without making any difference, if you can understand that, because there is further movement, but that does absolutely nothing for more power. It just saturates it, and I don't think that helps long-term reliability. So power set, deviation set, and the meter is set. So as far as I can see, we've now done the transmit. I'm trying to do the receive at the same time on these videos, as long as we're really taking less than 30 minutes. Otherwise it's difficult for people to trawl through to find the bit they need to do their own repairs. So I will move straight onto the transmit. Sorry, from the transmit straight to the receive. So plug our test instrument in. And I'll move the camera position to the synad meter. Okay, so actually before we go on to the synad meter, I thought we'll go on to the, but it helps if we switch the scope on. We'll go on to the detector coil. There's a lot of noise there. I don't know whether it's our signal generator generating the noise, or whether it's the radio with something else dry joint in the receiver. So coil 5 is the detector coil. So what we're trying to do, I'll just turn the volume up, is to get the maximum waveform on this other scale. I'll just turn the bench light off in the hope that we can see that better. So we'll adjust that for maximum recovered audio. Turn that up a bit more. It's there we have it. There's certainly some microphony there. Hope it's not the ceramic filter. Right, now we'll switch to the synad meter and we'll tune up the receiver, which, if I turn the squelch down, is receiving there at 0.3 of a microvolt. So I don't think we're going to be making much of an improvement, but there was an improvement by doing the detector. So with the bench light back on and looking at my sheet again, I'm expecting to tune it up 1, 2, 3, 4. We've already done 5. So it's T1, T2, T3, T4. Helps if we turn the synad meter on. So we'll turn down the signal generator till we get it to about 3 dog biscuits there. 1, 2, 3. Turn it down again. Use a yellow tool for the other one. So that's really sensitive. That's 0.06 of a microvolt. Not all the new sets work like that, do they? So if we set this to S9, we should have S9 on the meter. Just take that camera off because we're done with that. So S9 on the meter. Oh, these are hard to see. So we're at, that's 9. So we need to lose 2 of those. And I seem to think that variable resistor 2, I think it's variable resistor 2, is the bar graph. No, that's too harsh. I notice one of the segments is dropping in and out, and what that is it's ingress of dirt on the between the display and the, you know, you've got the glass display, you've usually got some what would you say, conductive rubber things between there and the printed circuit board it's mounted to, and I'm not going to strip that down. It's usually caused by nicotine. I'll tell you what, I will strip it down just to see whether it's something we can do easily. But what I don't want to do is end up with a broken display. It's not really used as serviceable. So we'll just have a look. So having just popped the front off, what we would have to do, and we're not going to, is we need to remove the retaining nuts for the volume and squelch control, for which you need a pin driver that we don't have. We could faff about with surgical scissors or something, but it's a long way down, and the last thing you want to do is the moulding to break. It's a customer's set, it's not our set. That makes a difference to what we do. So there's another possibility here, and the possibility when I take this apart is there is a gold-plated connector which mates up with the display. It's possible that the pins could be dirty. So what we're going to do is clean those with a fiberglass brush, and then we'll pop it back together. We're certainly not going to strip down that board to take that board out and then have the possibility that it doesn't go back together and the customer's radio is wrecked. So there is a limit to what we do with a customer's set. So I'm going to clean that with a fiberglass brush, and then we'll pop it back together. So the good news is that appears to have brought the bar graph back solid. So it was the connector between the two rather than the ingress of fine dust or worse still nicotine between the LCD panel and the printed circuit board. So having set that up, that's now S9. I still need to overcome this nasty noise, and the radio's generating the nasty noise. Listen. And if I unplug the radio from the test set, it's still there. It could be capacitors in the audio amplifier. So we need to set up the squelch. So with the signal generator off, squelch advanced to threshold, signal generator on, and it's straight in. Now with the squelch to full, Let's see when that comes in. Oh, it comes in at 1 microvolt. That's no good at all. So I've set the signal generator to 3 microvolts. The Squelch 3 preset is variable resistor 1, which is the one there. If you remember, that was the S meter, that's the Squelch. And let's hope. Well, that's doing a whole lot of nothing. Right, we'll run through that test again, but it's one of these wishy-washy squelchers again. So with the signal generator off, squelch to threshold, signal generator on, and in it comes, squelch to full, and 10 microvolts is the strongest it works. So that's actually with the Squelch preset at full, but the sensitivity is still there, and that's as good as it gets. I do like them to be able to squelch out S9, but of course you can't have that with every model of radio. They don't all have the same ideas as me, of course. So I don't know how you test the ESP, but what does happen is if we put a signal on and you press the button, it makes a difference. And the ESP lights up. Let's take it with, put it with no signal. ESP on, ESP off. But so when we had these in the car, never seemed to do anything for me. Now I'm going to just see if we can track down the source of the noise on the audio amplifier. I don't know whether we've got microphony, I don't know. I'll turn the tone off. It's there in the background. It's not noticeable with a signal. Well, it is. I was lying. So what I'm going to do, I'm going to inject a tone into the audio amplifier. But my feeling would be it's going to be some tied capacitors, because at the end of the day these are now 19 years old. So I'll pause the video. So looking at the circuit diagram, I'm assuming that this noise is generated by the audio amplifier. So my experience is that electrolytic capacitors can easily fail, and they're cheap enough to replace without running up the customer's bill unnecessarily. So we've got that one there. You can probably see this better than I can. I think that says 33 at 16 volts. You've got that one there, for capacitor 43, 1000 microfarads at 16 volts, and you've got that one there, which is looks like 470 microfarads at 16 volts. So I think we'll go for those three because they can generate noise, and they're cheap, and that's the experience. So I have some in stock, and we'll just pop those in. Part of the fault finding, the next thing I'm going to do is to see if we can track down the noise. It's probably done this from new, you know, you just don't know. Is to use our homebrew audio amplifier. So I'm going to see whether the noise appears on our audio amplifier. So I'm going to unplug the speaker through the test equipment, switch on our audio amplifier, and probe it at the volume control I'll probably have to put an earth on this. Wherever the volume control, oh there's the volume control. Yeah, so I'll get a bit of a crocodile clip and put that to chassis. So now put the signal generator back on. And this time it's coming through our amplifier only. And I can't actually hear anything now. I can hold that to the microphone. Put the signal generator back on with no audio. And the signal generator with audio. So if we fast forward a couple of days, I've ordered transistors for what I believe to be a noisy squelch circuit on this radio, but I have put it back together because we need to get on with other jobs and release the bench, and I didn't want to have the radio hanging around in bits. So we've put it back together. We'll have to wait a few weeks for those parts to come through, no doubt from China. So we've put it on Mr. Chippie's bench here in the backroom workshop. And I've connected it up to this external S meter through that 2.5mm jack socket which is on the back of the radio. And I said I'll do that. Now we've got one of these meters. They weren't ever that cheap. I think it was $29.99, that one. And what is it, Mr. Chippie? What make is it?
Euro CB.
A Euro CB, right. We've got it connected to our, is it 1.5 amp power supply?
It is, yeah.
1.5 amp Apollo power supply made in Italy. You don't see many of those, but more than adequate for normal UK CB use. So we've got it connected up. It's into a dummy load because I just wanted to show that S meter. Now I'm going to go in the other room and I'm just going to do a test count on this, and you'll see that the S meter will operate in unison with the digital display on the Midland.
Tango 21, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
So we've calibrated the two to read the same. So if you just point out there's a knob on the S meter there, that's it. And so the two are reading the same. But of course, if we go into transmit, the calibration isn't quite how we'd want it to be because we know the radio does 4 watts. So you key that up. And what does that read?
Well, it's
5.5? 6?
6
Yeah.
instead of 4.
They're good buddy watts, I suppose, instead of what we calibrated it to. So you could calibrate it so the power output is correct, but then the S meter would be out. So, you know, they have their disadvantages, but as an S meter, if you wanted to see something half decent, it was a useful feature to have added. So we're going to do on the air test with this radio tomorrow, and just make sure it works where we'd like it to, because we've not done one of these before. So that's we've done quite a lot to this radio. If you remember, we've done all the transmit, we've done the receive, we've done the faults, and so that's the Midland 98 repair video complete. So thank you for watching.